everyone. We're looking at a very famous formula developed by Albert Einstein, and it is energy equals mass times the speed of light squared. Basically allows us to compute the amount of energy in joules that would be produced by any mass or body that is accelerated to the speed of light. So this is actually a very simple formula. You know how to multiply. You know how to raise something to a power. So this is something we can do. Just a couple of details about this formula that we need to know is that mass is in kilograms, not pounds, as we tend to be used to. And then the speed of light is a constant, and that is known to be 300 million meters per second. So with that in mind, let's look at the application that we're going to write. So the user is presented with a text box in which he or she will enter his or her weight. So let's say we have a 100-pound person using the program, and they click the calculate button. Okay, so the number of joules is, of course, very large, but that's the nature of this program. Just so you know, the user entered his or her weight in pounds. So we do have to convert that behind the scenes before we do the actual calculation, meaning using our formula E equals mc squared. So let's look at the code. This is actually a pretty simple program, but there are just a couple of minute details that we need to be aware of. One more thing I want to point out before we look at the code is look at the output. This is a very long line of output, longer than we tend to be used to in this class. And what I've done is I've included line breaks. This label is actually probably about that size. Typically we make our labels about 25 pixels high. I made this one 100 pixels high, and so this would allow us to create a longer line of output that spans multiple lines. So I'll show you how to include a line break in your output, which is something that might be useful. Okay, so here we are in the code, and I'll just point out this line real quick. That's the one where I'm adding the label, and I made the label much taller than we're used to. So that's 100 pixels high by 400 pixels wide. So it's like a rectangular label. And now everything's wired up. The interface is in place. We're just going to focus on the code here. Remember that 1, 2, 3 approach that keeps coming up last week, and it'll come up again in all of the applications that you do this week. And that first step is always get the user's input. And really what that means in an application like this is you reach into that text box and you extract the contents, which is what the user typed into the text box, and we use the fccontrols.getText to extract the contents of the text box. So that'll be what I do first, and then once you have that, you're ready to go. You can calculate. All right, and remember the third step is always displaying the result to the user. Okay, by updating a label using setText. Okay, so with that in mind, let's move forward with this. The user enters his or her weight in pounds. My first order of business is to reach into that text box and get the weight in pounds out of the text box and put it somewhere. Where do we put anything in programming? Into a variable. So I'm going to create a variable that has a good descriptive name. You may be tempted to use a name like this, which is, of course, appropriate. However, we talked about the fact that the user is entering his or her weight in pounds. We're going to have to convert that to kilos. And so we're going to have two weights in this program when it comes down to it. So I'm going to be very specific here so I don't get confused. And I'll say weight in lbs or weight in pounds. So I know if I look at that variable, I say, oh, that's the weight in pounds as opposed to kilos. So we're going to use, as I said, fccontrols, getText, and This method, the getText method, requires one argument, and that would be the text box that we care about. And in this case, it's called txt weight. Okay, so that's step one. All done. Okay, now step two is to calculate. And before we dive into the E equals MC squared part, we have to convert the weight to kilos, okay? And 1 kilogram equals 2.2 pounds. Knowing that, I'm just going to type a very quick calculation. We'll say kilos equals the weight in pounds. And if we divide by 2.2, that'll do it. Okay, so now we're ready to plug this into the formula. I mentioned before that the speed of light would be 300 million meters per second. So we have everything we need to calculate the energy that would be produced. Okay, so step three, or no, I'm sorry, we're still in step two. We're doing the formula. So I can say E, or I could type out the word energy, but you know, we know what this equation is about. So E would be an appropriate variable name in this case. So we say E equals mass, which would be kilos, times the speed of light squared. Okay, and basically, you know how to raise something to a power, right? So, and we know that the speed of light is 300 million meters per second. So let's use math.power. And you know that this power method requires two arguments. First, the base, that'll be the 300 million, and then the exponent, which is what you're raising the base to, and that'll be 2 in this case because we're squaring the speed of light. So I'm going to type in 300 million meters per second. So that would be a 3 with 8 zeros. You may be tempted to do something like this. Don't do it. Don't put commas in a numeric constant, even if it's a very large number and it helps you. Often that'll mess things up because, you know, a comma, when we call a method which has multiple arguments, such as this one requires 2 arguments, how do we delimit those arguments? We type commas, okay? So what happens is the program thinks that this is the first argument, 300, and then we're providing 2 more arguments, and then finally the exponent. Now we've provided 4 arguments to a method that only requires 2, and it's not going to run. So you need to be careful about that. I know it's helpful to see those commas, but you just can't put them in this case. So anyway, we have 300 million squared, and that'll do it. And, you know, just one more quick thing I want to point out. This is another thing that you have to be careful of. I see students doing this. In a math class, it is perfectly appropriate. Well, let's look at this formula again. If this were a math class and we were writing on paper, this would be a perfectly appropriate thing to do. When we see 2 variables or 2 things side by side, we assume that they're being multiplied together. Mass times the speed of light squared. There's no multiplication symbol in this equation, but we know what this means. When you see 2 values side by side, they're multiplied. However, when you're programming, you can't do something like this, so be careful. You may say, okay, you know, the mass is the kilos, here's the speed of light squared, I put them side by side, they're being multiplied. No, they're not. You always have to explicitly put a multiplication sign, which is the asterisk in this in most languages, I would say. You always have to physically put that sign in. You can't, you know, assume multiplication when 2 things are side by side. So be careful. That is a mistake I see students make a lot. All right, so anyway, we're ready for step 3, which is to display the output to the user. And basically, I showed you the output and how especially that number that's calculated, it's very long, and it helps to be able to continue your output to the next line or wrap to the next line. And I'll show you how to do that. Basically, what we can do is create what we call a new line character. So I'm going to come up with a variable name. I'm going to call it new line. I made that up, okay? But that would be typical in a case like this. So we'll say text dot get character. There's this built-in get character method, and what you can do is provide it a number. Now, I already looked up this number, so I already knew it. And if I say, hey, get character, here's a number 10, get character will in turn give me a new, basically, it's almost like the enter key on the keyboard. It's a new line. It'll give me a line wrap or a line feed, okay? So now that it's in the new line, I can just insert this new line variable into any part of my output, and it'll wrap to the next line. So I'll give you an example. We'll update the label. So we'll say, you know what, why don't we create a variable? So we're going to have a really, really long line. I'm going to create a new variable called message equals, okay, and then the output is something like this. Your total annihilation would yield, okay, and then we'll concatenate to that the number of, now we have a new line coming up, so we'll concatenate to that the new line. All right, and then on the next line we'll put that huge long number that's produced, the number of joules of energy, and then we'll wrap to yet another line. Remember that the output span 3 lines. Okay, and then we'll say joules of pure energy. Okay, so now this whole thing is in the message variable. Okay, now it makes it really easy to call the set text. So we'll say FC controls set text, setting the text of the label. It's called LBL message. That's our tall label that'll display the 3 lines nicely. And what are we displaying in the label? The message that we just built on the previous line. Okay, so that'll do it. Let's run.